Today we're going to talk about three other types of quadrilaterals. We're going to start out with a rectangle. And at the beginning of this chapter, I said the hardest thing you're going to have to do, like last chapter you had to learn vocabulary, this chapter you've got to learn properties that go with each of our individual shapes. And you've got to remember which one has which property. So we are going to talk about properties that are unique to a rectangle today, as well as a square and a rhombus. The first thing we're going to do is define a rectangle. I'm positive most of you could identify one, but I'm not sure that we could all define it. It is a quadrilateral. In other words, it has four sides with four right angles. I know that this shape is a rectangle because I can see that all four of the angles of my quadrilateral were 90 degrees. Because opposite angles are congruent, not only is this a rectangle, but it is also a parallelogram. So everything that's true about a parallelogram is also true for a rectangle. And there'll be additional things that we talk about in a minute that are true only in the rectangle, not in the parallelogram. It has a couple additional properties. But we should be able to identify a rectangle by looking at it and seeing that it has four right angles. Next is the rhombus. Again, a special type of quadrilateral, so when we're defining it, it is a quadrilateral with four congruent sides. You can see that RH, HO, OM, MR, all four sides are marked as being congruent. That makes this a rhombus. Since opposite sides are congruent, every rhombus is a parallelogram. Everything that's true about a parallelogram is also true about the rhombus. And it has a couple additional properties that we're going to talk about in a minute. This is just simply so we can identify it and we know what its definition is. A square. It is a quadrilateral with four congruent sides and four right angles. A square doesn't really have any properties unique to itself. Because opposite sides are equal, it has all the properties of a parallelogram. It has all the properties of a rectangle because it has four right angles. It has all the properties of a rhombus because it has four congruent sides. So it really doesn't gain any new properties. It takes the properties from each of these three different shapes. So, notice that the properties of a rectangle start out with what? Properties of the parallelogram, which we talked about a couple days ago. These are the first 5 properties that every rectangle has. it has two additional properties. The first one comes straight from its definition. Every rectangle has 4 right angles. So I can see where the A is, that was 90. Where B is, that's 90. C is 90. Where D is, that's 90. The other thing that happens is, not only do the diagonals bisect each other, but if it is a rectangle, the diagonals are congruent. In other words, I know that whatever AC is, that BD is going to be the same. In fact, because they bisect each other, all 4 pieces of these diagonals would be what? If I told you one of them was 10 units long, all of them would be what? 10 units long. So, we need to remember that there's 5 properties for a parallelogram. There is 2 additional properties with a rectangle. That it has 4 right angles and the diagonals are congruent. Pretty good so far? Properties of the rhombus. What do we see it starting out with again? It starts out with what? All the properties of a parallelogram. Opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, diagonals bisect each other. The first additional property it has comes from the definition. It has 4 congruent sides. All the sides have the same length. The diagonals are perpendicular to each other. In other words, if I drew a rhombus in here, and I marked all these sides as being congruent, when I draw these diagonals in, this is going to make a 90-degree angle. They're perpendicular to each other. The diagonals also bisect opposite angles. And again, if I go up and I look at my picture, if it bisects this angle that's up here, it cuts this angle into 2 equal pieces, and these 2 pieces would in fact be the same. They're opposite angles. It would bisect this angle. These 2 pieces would be the same. Likewise, these 2 up here would be the same. So we have the 5 properties of a parallelogram, and we have 3 additional properties for the rhombus. It will create 4 congruent sides. The diagonals will be perpendicular. In other words, they'll meet to form a 90-degree angle. And the diagonals will bisect the opposite angles. Everybody good so far? Can I go forward? Properties of a square. Notice there's nothing new this time. It has all 5 properties of a parallelogram. It has the same 2 properties that a rectangle had. What were our 2 properties for a rectangle? It had 4 right angles. And its diagonals were what? Not in a rectangle, diagonals were what? Congruent. The rhombus had 4 congruent sides. The diagonals will be perpendicular, and the diagonals will bisect opposite angles. So far we're dealing with 4 different shapes. We're dealing with the parallelogram, which had 5 properties. We're dealing with a rectangle, which had 5 properties plus 2. We're dealing with a rhombus, which had the 5 properties plus 3. And then the square, which has 5 properties plus the 2 from the rectangle and the 3 from the rhombus. Questions so far? So, here's what we have. We start out in this picture where everything that we've been talking about is a quadrilateral. In other words, it has what? 4 sides. There's all sorts of different quadrilaterals. I could be talking about a trapezoid. I could be talking about a kite. But then we talked about something specific. We talked about a parallelogram. And a parallelogram, we knew that the opposite sides had to be parallel to each other. Today we talked about special types of parallelograms. We talked about a rectangle, which meant my parallelogram now wasn't just opposite sides parallel, but also had what? 4 right angles. We talked about a rhombus. Not only was it a parallelogram, but it was the kind of parallelogram where all 4 sides were the same. And where the rhombus and the rectangle overlap, what's going to be in here? Our square. So everything that's in here not only is going to have 4 right angles, but it's also going to have 4 congruent sides. If I was looking at this diagram then, it tells me that every square is a rectangle, but not every rectangle is a square. Every rhombus is a parallelogram, but not every rhombus is a square. All of these are quadrilaterals, but not every quadrilateral is a parallelogram, a rectangle, square, or rhombus. Everybody good? Next slide. Okay. So, some of your problems are going to be just as simple as identifying. Are we determining whether it's a parallelogram, a rhombus, a rectangle, or a square? So, example 1, what is it? Take a look. What did they mark? They marked 4 congruent sides, so it is a rhombus because it has 4 congruent sides. What is example 2? It's a square. How do we know? It has 4 congruent sides, and it also has what? 4 right angles. Example 3. It is a rectangle. It has 4 right angles. Be careful before we answer example 4. What is example 4? Well, it's definitely a parallelogram, but it may be more specific. If one set of sides is both parallel and congruent, this makes it a parallelogram. But remember, all the properties now are true for a parallelogram. What can you tell me about opposite angles? They're congruent, so this would be 90 degrees. What can you tell me about consecutive angles? You're right. They're supplementary. So if this one's 90, this one also had to be what? 90, which means this one's what? What shape is example 4? It is a rectangle. I don't know that the other set of sides are congruent to the side that I already have, but I do know that it's going to have 4 right angles. So it will be a rectangle. Everybody okay with the first 4 examples?
If this was on the test, we would have to say, like, how is it?
Possibly. You might just have to name what it is. Okay? But if you know the definitions, you should be able to tell me why you know that it's a rectangle, a rhombus, a square.
Okay.
And since the property is included as part of the definition, you almost have to know it anyway. Other questions? Okay. This picture is a little hard to see, and I apologize for that. It's even a little hard to see there in front of you. It's kind of small. So, for the sake of argument, I'm going to pull some of my picture. I think I can. Well, maybe I can't even get it. I can't even make it any larger. Let's see if I can snip it this way. I'm going to make the picture a little bigger up here so it's easier to see. We'll go back to answer the questions in a minute. When you get a picture like this, where they're asking for obviously more than one thing, I like to work the picture before I start answering the questions. Okay? If this is 13 here on the outside and they told me that this is a rhombus, how big are all the sides? 13. And I'm just going to go around and mark that. They told me from F to K was 5 units long. How far is it from K to H? It's also what? 5 units long. Okay? Now, that takes care of anything that I can do with segment lengths for the moment. I do know that diagonals bisect each other. So I know if this was 41, that over here is also what? 41. And since opposite angles are equal, both of these up here are also what? 41. I do know that whatever is here has to be here, has to be here, and here. So 3, 5, and 2 are all going to be the same. Well, what else do we know about the diagonals? Not only did they bisect opposite angles, how did they meet here in the middle? Look at the properties of a rhombus. What does it say? The diagonals are perpendicular. So this is going to be 90 degrees, which means each one of these in the middle is how big? 90 degrees. Now let's look at this triangle. How many degrees are in a triangle? There's 180 degrees in any triangle. So far, I've used 41 and 90. I've used 131 degrees in this triangle out of 180. So the one that's remaining had to be 49. So if this one's 49, each one of these that I have marked with the double mark is also 49. Everybody with me so far? There is only one other value that I know that they're looking for. They're looking for something about this diagonal. I do know that whatever this piece is going to be the same. And we can actually find that information from this highlighted triangle. This is what the triangle looks like if I separate it out. This is 5. This is 13. And this is what I'm really looking for. I want to know how big this is. If I know two sides of a right triangle, how can I find the third side? These are sides, not angles. Everybody remember seeing Pythagorean theorem in your past? Remember that the C side of a triangle has to be the hypotenuse. The other two sides don't matter. So I'd have 5 squared plus x squared equals 13 squared. 5 squared is 25. 13 squared is 169. I'd subtract 25 from both sides. I'd have x squared is equal to 144. And what's the opposite of squaring something? Finding its what? Square root. The square root of 144 is 12. So each one of these pieces is going to be 12. So now I filled in all the pieces that are in that original picture. This was 13, 13, 13, 13, 5. Angle 2 was 49. 3 and 5, 3 was 49. and this was 12, this was 12, this was 41. So any one of these questions I should be able to answer. Angle 1 was 90 degrees because it made perpendicular line. Angle 2, 49. Angle 3, 49. Angle 4, 41. From K to J was 12. From F all the way to H is 10. We'd add the two 5s together. When you get a problem that has many things going on the inside, do yourself a favor. Put everything that you can into the picture before you start answering questions. If you don't, what's going to happen is the first question you're not going to know what to do, and all the rest of them you're going to leave what? Blank, because you're going to think you don't know how to do any of them. Do yourself a favor. Work the picture. If you had worked the picture, chances are, if there was one of them that you would have missed, it might have been this one. All the rest of them you should have been able to fill in pretty easily. So do yourself a favor, work the picture, and then start answering the questions. Mathematically, this is the toughest one that we had to do today. The last examples. They said we have a rectangle. If you have a rectangle, what should you do? Draw a rectangle. Now they gave me information about my rectangle. They said from A to C, this whole length was 3x plus 7. They said from D to B, this whole length was 5x minus 11. But what can you tell me about the distance from A to C and the distance from D to B? They have to be the same. If it's a rectangle, the diagonals will be congruent. So 5x minus 11 has to be equal to 3x plus 7. Subtract 3x from both sides. 2x minus 11 is equal to 7. Add 11. 2x is equal to 18. So when I divide by 2, I get x is equal to 9. They asked me to find the value of x. I did that. They also asked me to find the length of the diagonal. So I've got to take that 9 and plug it back into one of these. 3 times 9 plus 7. 3 times 9 is 27, plus 7 is 34. So x is 9, and the side is 34. Questions? Example 12 is exactly the same type of problem. First thing I'm going to do is draw what? I'm going to draw a rectangle. They said from A to C was x. They said from B to D was 4x minus 12. What am I going to do with these two values? Set them what? equal to each other. If I subtract 4x from both sides, I have a negative 3x equals a negative 12. When I divide by a negative 3, I get x is equal to 4. If I plug that back into either one of these, the side length is also what? 4. There's my two answers. Questions? There's your assignment.